Hello, I was very short on time when I returned quiz number 3 and I haven't talked about it, so I thought I would include a little video where I show you how to do these problems, but also I want to make some comments. So far there are some people who I think are probably a little disappointed with their quiz scores. So what I really want you to ask yourself is, what is your day-to-day study process? To what extent are you going and really reading your notes very carefully, going through like examples step by step and thinking about it, as opposed to just kind of nodding along and saying like, oh yeah, I did this and it made sense? Very often things that made sense at the time you still haven't fully assimilated. Read the notes really carefully to get those concepts correct. The things that I type in the paragraphs, maybe you weren't paying attention to them in class, but go back and read what I said and do the odd practice and check. The only way you really know if you can do the problems is by doing problems. I think it's very easy to trick yourself into thinking it's fine. I will say thus far, I haven't been getting a ton of questions about problems that, in my opinion, are kind of hard. So that could mean that everyone is doing them and getting them correct. But given what I've been seeing on the quizzes, I think what's happening is people are not doing everything. Maybe you're doing something and rounding it up to, oh, I did the homework. But if you're really not doing every problem and checking your work, that can be a problem. Now, there are some problems that are quite tricky, and if you get them wrong, it's not really a big deal. And if you ask me about them, I'll tell you, like, oh yeah, that one has a really tricky factorization, don't worry about it. But if you are getting lots and lots of practice problems wrong, and you're not learning from your mistakes, that's problematic. So if you've been doing not so hot on the quizzes so far, I really urge you to take your day-to-day study practice more seriously. And then also to think more with more intent as to what should go on those index cards. Maybe on the index cards you have to have a little more in terms of vocabulary and big picture ideas, as opposed to just copying the steps of some example. Right? It's early in the year, but start trying to figure this out. Okay, so let's take a look at this. So we're finding these limits. These are all limits going to infinity in some way. This first one's a rational function. We have a rule that says with a rational function, only the biggest term of the top and bottom matter. So this is the limit as x goes to infinity. I'll make my pencil a little smaller. Of 4x squared over 8x cubed. I'm doing this rather formally. You didn't really have to show detailed steps, so if you left out the limits because it's just your own personal calculation, that's fine. Okay, so this is the reduced form, and some people got here and still didn't quite get the right answer. This is 1. 2x is huge, so 1 divided by something really huge is super duper tiny, and in the limit of something super duper tiny, that limit would be 0. You might just remember a fact from pre-calc that says any proper rational function, a rational function where the degree on the bottom is bigger, has y equals 0 as a horizontal asymptote. With polynomials, we can also just ignore the small thing. And here you can sort of just imagine that x is a huge negative. If you thought about the graph, that's great too. If I take 3 times a huge negative to the third power, that's going to be another huge negative. So in the limit, we would have negative infinity. All right, now for this one, right, this one threw some people off because people were looking for a rule to follow instead of just thinking about this. Cosine, even if you forget, exactly what the details are, you should certainly remember that the graph of cosine is a wave that just goes on and on forever. So as we approach infinity, it goes up and down and up and down and up and down and up and down and doesn't settle down at any particular y value. There is no horizontal asymptote here. So this limit does not exist. It doesn't go to infinity, it doesn't go to negative infinity, it just goes up and down and up and down and up and down and up and down without settling on any particular value. And this last one had a bit of a trick. We did see an example like this in class and one in the odd practice, but it threw some people off. The 12 doesn't really matter because we're talking about x being huge. the square root of 9x squared would be 3 times the absolute value of x squared. As a general rule, square root of x squared is absolute value. It comes out positive over 12x. So what we're noticing is that these two things are basically the same. But this is positive because it's an absolute value. This is negative because x is approaching negative infinity. So the things in yellow cancel out to negative 1. So we have 3 over 12 times negative 1, which is negative 1/4. Now the second side, part A is a little open-ended. I was very generous in how I graded, and also some people kind of put information here that should have gone down here. I read everything and tried to give you as much credit as possible. So in terms of what continuity looks like, and you can be very brief, but we could say at x equals 4, there is no jump, hole, or vertical asymptote. That's the gist of what continuous means. Some people were saying there is no discontinuity, and that's a bit circular, right? You're saying, oh, continuous means it is not discontinuous. I really wanted you to use at least some of these words like jump or hole or vertical asymptote, or some sort of verbal description that the graph, is connecting in some way. But in terms of the definition, you straight up need to know this definition. And if you have the right picture in mind, right, let's just draw a little picture. Here is my function that is absolutely continuous at 4. Here's my graph, y equals h of 4, and there nothing strange is happening. In terms of the definition, what that means is the limit as x approaches 4 of h of x, the value that we are heading towards as we follow along this graph is the same as the value we get. And then sort of the fine print here, although this is the real gist of it, where both sides have a numerical value. That's, in my opinion, that's implied, but I don't want to think that it's some sort of really weird thing where like, oh, undefined equals undefined, so that counts. No, the number I get from the limit is the same as the number I get from the function. Just this is the gist of it. One thing I'll just point out, I said use correct notation. That's your signal that there should be notation in your answer. Some people gave answers here that were completely verbal without any limits or anything like that. Right? There's a little signal here. If I say use correct notation, then that's your signal that there will be mathematical notation in the answer. Okay, so that is this video. Some of you did really well, which is great. For the rest of you, I hope you learned something from the video.